Okay, so for worksheet 1, 7.1 identities, I gave you some hints. The first hint for number 1 was FOIL the binomials and then look for Pythagorean identities. So when you FOIL this out, if you need to write sine theta plus cosine theta times itself and just FOIL everything out and add like terms, you can do that. I can do that without having to show all that work. I know I'm going to get sine squared. My middle product, my outer and inner product, I'm going to get 2 sine theta cosine thetas. And then when I take the last terms, I'm going to get cosine squared theta. So that's what you get when you FOIL out the first one. If you FOIL out the second one, you're also going to get a sine squared theta. You're going to get a minus 2 sine theta cosine theta. And you're going to get a plus cosine squared theta. That's what you get for the second one. And I want to show that that equals 2. Okay, so I start to look and see that, okay, these are going to cancel out. So I have a sine squared theta plus cosine squared theta. That is equal to 1. And then I have sine squared theta plus cosine squared theta again. That is equal to 1. So the whole thing equals 2. So after you FOILed them out and then realized Pythagorean identities, you're good on that one. All right, number 2. The hint I gave on number 2 was factor out common factor from the left side and then use Pythagorean identities. So I'm starting with the left side. It said factor out the common factors. So I have a secant to the 4th and I have a secant squared. So I'm going to factor out a secant squared. So I'll be left with a secant squared theta minus 1. Remember, I have to take it out of each of those terms. So then in the parentheses, I'm left with secant squared minus 1. All right, then it says to use Pythagorean identities. So secant squared, if you go back to your Pythagorean identities, if you forget, remember, you always want to start with sine squared plus cosine squared is 1. And then say, okay, if I want to get to secant squared, I need to divide everything by cosine squared. So I'm going to get sine over cosine, which is tangent squared plus 1 is equal to 1 over cosine squared is secant squared. So secant squared is 1 plus tangent squared. So you need to make sure you start to know these without looking at your notes. And then secant squared minus 1. So if I know that I have secant, or I have tangent squared plus 1 is secant squared, then if I look at that and say secant squared minus 1, that would be tangent squared. So I don't need to see any of this work over here. In fact, if you do that work, make sure it's off to the side. You should just be able to figure out that secant squared is 1 plus tangent squared, and secant squared minus 1 is tangent squared. And then if I distribute this tangent squared to each of these, I'm going to get tangent squared theta plus tangent to the 4th theta. And that's where I was trying to get to, so I'm good. Okay. All right. Number 3. My hint on number 3 was to add fractions. You need to get a common denominator. That was the first step. So looking at that and saying, okay, I need to start over here and add the fractions. So 1 is really 1 plus sine over 1 plus sine. So I really can just rewrite that 1 as 1 plus sine over itself. So what does that mean I have? I have 1 plus the sine of theta minus cosine squared theta all over 1 plus sine. All right, that was the first step, adding fractions. Then it says use Pythagorean identity. So Pythagorean identity is the sine squareds and cosine squareds. So looking at this thing, I mean, a couple ways I can look at it, but I either could replace that cosine squared with 1 minus sine squared, or I look at this and say, all right, 1 minus cosine squared is sine squared. So I'm left with sine squared theta plus sine theta over 1 plus sine. Okay, so all I did is I replaced the 1 minus cosine squared with sine squared. All right, then it says factor numerator. So if I look in the numerator, there's 2 terms. They have something in common. They have a sign in common, so I'm going to factor that out. So I'm going to get the sine of theta times the sine of theta plus 1. Still all over 1 plus sine theta. Now, why did I do that? Now I look to see that, oh, those cancel out. And so I'm just left with sine of theta. And that's what I wanted. Okay, so again, I looked at that and said that I needed to do something over here. So I got like denominators, added them. Anytime you see that cosine squared, think about that Pythagorean identity. So 1 minus cosine squared is sine squared. Knowing that you wanted to get rid of this, and knowing you only wanted to be left with the sine, hopefully you could see that, oh yeah, I need to factor out a sine theta. And then you could see that they go away. All right, let's try number 4. 4 looked a little complicated to get started. And again, I gave you a hint on that one. Let me talk about why I get some of these hints. On 4, I would look at this and say I can't do a lot with the left side, so it'd tell me I'd probably want to start with the right side. And usually if you don't know what else to do, and there's no squares, put everything in terms of sine and cosine. So in 4, I said start with the right side, use reciprocal identities, which means cosecant is 1 over sine. So I'm going to start with this side, and I'm going to say that is equal to 1 over the sine of theta plus 1 over 1 over the sine of theta minus 1. Okay, that's what the cosecant is. Then my hint said to multiply fraction by a form of 1 to simplify the complex fraction. So anytime we have these complex fractions, a fraction inside a fraction, you need to get rid of that denominator. So to do that, look at your least common denominator, which is sine. When I said multiply by a form of 1, it just means I want to multiply both terms in the top by sine, and both terms in the bottom by sine. So when I do that, 1 over sine times sine is 1 plus 1 times sine over 1 over sine times sine is 1 minus sine times 1 sine. And that's where I wanted to get to. So, when you're trying to decide which side to start with, if you can't do anything with this side, then look and ask yourself, what can I do to start with this side? So we put it in terms of sine. Then we see anytime you have a complex fraction, you always want to get rid of that complex fraction. So just multiply by some form of 1. We just multiply by sine over sine, and we were left with what we wanted. So I think I'll stop there and do the second part of the worksheet, or the back side of the worksheet on a different video. So hope that helped.